Hello everybody! So welcome to our first video lesson for Chapter 7. In today's video we're going to be exploring some of the rules that we investigated today in class and finalizing some procedures and rules that we can follow to simplify exponent questions. Today specifically we're going to be looking at the product and quotient rule. Before we start this, I'd like to go through some vocabulary words that are going to be coming up a lot in this chapter to make sure that everybody understands what these words mean so that when I refer to them in the future, you're familiar with the terminology. So the first word is base. So when I look at an exponential expression like this one, the reason we call it an exponential expression is that we have an exponent. But there are two parts to an exponential expression. There's the base and there's the exponent. The base is the thing that is being multiplied, and the exponent is the number of times that we are multiplying it. So for example, x to the third power would mean x times x times x. The reason that we multiply this 3 times is because the exponent was a 3. Now sometimes our base is instead of a variable like the x, sometimes our base is a number and our exponent is the variable. And sometimes both the base and the exponent are variables. So sometimes, like in this problem, the base is a variable like a, and the exponent is a variable like b. One of our procedures that we're going to follow to explore these rules is to write out problems. So for example, if I wanted to write out 2x to the third power in expanded form, what I would do is I would write 2, and then I would write times x times x times x. One common mistake here would be to write the 2 more than once. For example, to say 2x times 2x times 2x. So one common mistake would be to say 2x times 2x times 2x and repeat the 2 3 times. But one important distinction to make here is that the exponent, the 3, is only attached to the closest base, the x. It is not attached to the 2. The 2, as a matter of fact, has its own exponent. It's just invisible. Its invisible exponent would be a power of 1. So basically, if you don't see the exponent there, it's automatically a power of 1. Let's go ahead and look at some problems that we can figure out some of these rules using some writing out the long way. So for example, if I said simplify the following, I could rewrite this problem x to the 5th times x to the 3rd like this. I could rewrite x to the 5th as x times x times x times x times x 5 times. I could rewrite x to the 3rd as x times x times x. Now when I write it out like that, I can see this is really one big long multiplication problem. So if I wanted to simplify that, I could say, well, in total here, I am multiplying x together 8 times. So my simplified answer would be x to the 8th. Now let's look at the pattern. Is there a connection between what we started with and what we ended it with that would allow us to skip this writing it out the long way step? Well, one thing I notice is that if I take the original exponents, the 5 and the 3, and I add them together, I get 8. So the pattern here is that the final answer, or I guess the pattern would be that we add the exponents when the bases are the same, and we are multiplying these problems together. So here's what I mean by the bases are the same, is that these both had a base, which is this thing right here, the bottom, of x. If this had been y's, 3 y's in a row, I wouldn't have been able to simplify it quite the same way. So in general, when we write this as mathematicians, what we usually write is this: x to the n times x to the m is equal to x to the n plus m. So basically, if the bases are the same, so that's this part right here, the bases are the same, and we have a multiplication problem, which is this right here, we're multiplying, then we just take the exponents, the n and the m, and we add them together. Now let's look at what happens in a division problem. So if I wanted to write this out the long way to see if I could identify the pattern, I would write x times x times x times x times x, because that is x to the fifth, divided by, and then I would write out x to the third. So that would be x times x times x. Now when I see that, I notice that 3 of the x's cancel from the top and the bottom. So all that would be left over would be x squared, because there are 2 x's left over. Well, if I want to see a pattern for how I could get to this answer without writing it out the long way, what I notice is that I can just take the original exponents and subtract them to get my new exponent. So the pattern is that we subtract the exponents when the bases are the same and we are dividing. So again, the bases need to be the same. It's important that these were x's. That's what made them cancel. If I had y's in there somewhere, it wouldn't work the same way. And it's important that we have a division problem. One of the ways we usually write out this rule mathematically is that if you have x to the n divided by x to the m, the answer would be x to the n minus m. So again, I have the same base. I have a division problem. All I'm going to do is take the exponents and subtract them and keep the base the same. So let's look at some examples. So the first example here, we're going to try it using the rules and then verify that we are correct by writing it out the long way. One really important thing we're going to be practicing in this chapter is how do you check your answers? How do you make sure you got the right answer? So we're going to write this out in order to check to see if we were correct. So according to my rules, when I saw problem number 1, I would think, well, I have a multiplication problem and I have two terms or 2 factors of that multiplication problem that have the same base. So my answer would be the same base, and then I would just add the exponents together. 5 plus 6 would be 11. And that would be my answer. Now if I want to write this out the long way, I could write x times x times x times x times x, that's 5 x's. And then I could write times x times x times x times x times x times x. That's 6 more. And all together, there would be 11 x's, which is why my new exponent is an 11. So we've checked ourselves. It makes sense the long way. It makes sense using a rule. One of the next rules that I know is that when I'm dividing and I have the same base, I subtract the exponents. So my base would still be y, and then I need to recognize that the invisible exponent by the bottom y is a 1, because if there's nothing there, it should be a 1. So I'm going to subtract. 8 minus 1 would give me 7. I would subtract these and I would add these. So we could write this out the long way. We could write out the numerator by writing y times y times y times y, 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 and y. That's 8 y's in a row. And we could write out the denominator by just writing out one y, because there's only one of them, which means one of the y's cancels, so there are only 7 y's left, which is why my exponent is a 7. Let's take a look at problem 3. Using the rules, I would say, well, I know I've got a 3, and that's not going to change, but now the x is going to have a new power, and I would just add my old powers together because this is a multiplication problem. So I would have x to the 7th. But if I want to write that out the long way, what I could write is 3 times x times x times x times x, so 4 x's, and then times x times x times x. All together, that makes that there are 7 x's, which is why my new exponent on the x is a 7. Let's take a look at the next one. So 6y to the 7th divided by 3y to the 4th. So, using my rules, I know if I look at the numbers first, 6 divided by 3 is 2. And then if I look at the variables second, y to the 7th divided by y to the 4th would be y to the 3rd. I would just subtract the powers, 7 minus 4. So I would have y to the 3rd. I'm basically just treating the numbers like one division problem and the variables like another division problem. Now if I want to write this out the long way, I could write 6 times y 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 divided by 3 times y times y times y times y. And then I would see the 6 and the 3 divide, and they make 2. That's where that 2 came from. A bunch of the y's cancel. So 1 of them, 2 of them, 3 of them, 4 of them, which means I only have 3 y's left, which is where that y to the 3rd came from. Last or second to last would be if I have one big long multiplication problem. So if I'm looking at this, I notice that there are really two different things going on here. There are the factors of my multiplication problem that have an x, and there are the factors of my multiplication problem that have a y. So all I would do is do them separately because I know I can't combine things unless they have the same base. That was one of the rules we wrote down on the previous page. The bases have to be the same. So I'm going to combine the x's by adding their exponents together, and I would get 11. And I'm going to combine the y's by adding their exponents together, and I would get 15. So now what if I wrote this out the long way? Well, the long way, I would write x times x times x times x times x times x, and then 5 more of them, 2, 3, 4, 5, and then I would write out times 1y, 2, 3, 4, 5, 6, 7, and then another one times 1, 2, 3, 4, 5, 6, 7, 8. Oh my gosh, so many. Now if I simplify the first part, these all combine to make x to the 11th, and these all combine to make y to the 15th. And that is why we have rules, because that doesn't seem like a good strategy to use regularly. It seems like that would take a really long time. So, last but not least, let's do a slightly more complicated problem, but I know we can handle it. If we write our answer using rules, let's just do one thing at a time. So let's start with the numbers. 10 divided by 2 would give me 5. x to the 8th divided by x to the 6th, I would subtract those exponents and I would get 2. And y to the 9th divided by y to the 5th, I would subtract those exponents and I would get 2 because 4 because 9 minus 5 is 4. So I would subtract 8 minus 6 and get 2 for the x's exponent and 9 minus 5 and get 4 for the y. Now if I wanted to write it out the long way, it would look like this. 10 times 1, 2, 3, 4, 5, 6, 7, 8 x's times 1, 2, 3, 4, 5, 6, 7, 8, 9 y's divided by 2 times 6 copies of x, 4, 5, 6, and 5 copies of y, 1, 2, 3, 4, 5. Which means the 10 and the 2 divide, and that would give me 5. Cancel, 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 cancel. So I would have 2 copies of x left. And cancel, 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 cancel. So I would have 4 copies of y left, which is the same thing I got before. It's just 2 different options for doing the same problem. All right, guys, thank you so much for watching and have a great night. I will see you tomorrow at school for some practice.